This is a quick tutorial on how to use Excel to organize some data and create graphs. I've generated a random data sample using the Australian Bureau of Statistics. I'll put a link in the description so you can generate your own sample and have a go at doing some of these processes yourself. So the data we have here is gender, age in years, and reaction times. So that's the time it took them to respond to a reaction task. Now, let's say first we want to ask the question, does gender influence reaction time? Gender is categorical data, which means we can create averages and compare the average reaction time for males versus the average reaction time for females. And Excel can help us to do that. The first step to make things easier is to resort the data. You can see at the moment that male and females are mixed in at random. If we want to group all the males together and take their age and reaction time with them, we can do that by clicking the first gender in the column. So underneath the title of gender, we've clicked the first piece of data, M. We're then going to sort, and when you're under the Home tab, sort should be over this side here, sort and filter. You can then sort alphabetically A to Z, or in reverse alphabet, Z to A. If I click sort, you can see now that it has put them in alphabetical order. All of the F values are together, followed by all the M values together. When it rearranged those, it took the values from the next two columns as well, so the ages and reaction times are still paired with the correct genders. Now this will make it easier to calculate our averages. You could also, if you like, color code to help clarify the different categories you're looking at. So by making the male green and the females yellow, it just makes it easier to see the different groups. To calculate averages in Excel, you can use Excel formulas. So select where you want the average to go. So I've selected male mean value, an empty square where I'm going to put that value. To type into the box, you can click up here in the formula bar and start your formula with equals average, open bracket, and now I need to select the values that I want it to average. So I'm doing the mean value for the males, which means I need to select the male reaction times. And you can see it's filled in the codes C16, which is the first square here, C16, to C21, which is C21. If you want to, you can enter the codes manually, but I find it easier just to click and drag to select the ones that you want. Remember to close the bracket at the end before you press enter, and it should then calculate your mean value for you. It, in this case, has given us a value that is 0.4065. That is one more decimal place than most of these values have. If you want to change the number of decimal places in an answer that you've been given, you can use these two buttons here, still on the Home tab. We can increase the number of decimals or decrease the number of decimals there. Now, if I want to create the average for females, equals average, and select now all of the reaction times for the female group, remembering to close the bracket, press enter, and it calculates the average. That's way too many decimals, so we're going to reduce the decimals down to just 3 decimal places. Now, we use the word average. This is calculating the mean, which is the type of average you may be used to using more often. But you can also calculate a median and a mode and a standard deviation. For those, you just use the same technique, but a different instruction. So equals median, open a bracket, select the values, remember to close the bracket, press enter, and then we can always remove extra decimals. Same for females, equals median, open bracket, values, close bracket, enter. The mode value equals mode, open bracket, select the values, close bracket, enter. We've got NA as our response here, which means that none of these values repeat. Therefore, there is no mode value. We do the same for female. We find again there is no repeated value, so there is no mode for this data set. Depending on the data that you're using, you will have to decide whether you're going to use the mean, median, or mode as your measure of central tendency. The standard deviation as well can be used to tell how big the range in your data is or how close the values are to the mean value. So to calculate standard deviation, it's equals ST DEVA. So ST for standard, DEVA for deviation. ST DEVA, then open the brackets, select your data set. So reaction times for males, close bracket, enter. And again, equals ST DEVA, open bracket, select the data, close bracket, enter. And we can reduce the decimals down if we like, or increase them. So remember that the larger the standard deviation value is, the greater the spread in the data, which means the further away the values may be from the mean. Now, if we want to graph these averages, we'll select the appropriate measure of center. In this case, we'll go with the mean. You wouldn't graph the mean, the median, and the mode. You're going to pick the one that you think best represents your data. You can try selecting the data, including the titles. So we have male and female with the data sets underneath. And I've also selected that it is the mean. If you then click on the Insert tab at the top, and here you have a selection of recommended charts to choose from. Because this is categorical data, we're going to use a bar chart or histogram and a simple 2D column. And we click, and it creates the graph using the settings that it thinks are appropriate. Now that process of first highlighting the data and then going to insert chart doesn't always create a chart with the appropriate settings. It'll create the settings that Excel thinks you want. Sometimes a more straightforward approach is simply to select an empty space and insert a blank chart. You can now select the data manually. So the design channel should be open with the graph selected. You can then go select data, add series. You can give the series a name, but in psychology we don't use titles on our charts, we use captions underneath. So we'll remove that title at the end anyway, so we'll leave that blank. For the values, remove what's in the box and select your two values that we are plotting on our graph. And you can see the chart has now filled them in. Select OK. Now you can see that instead of labeling them as male and female, they're just called 1 and 2 at the moment. You can edit the labels on the bottom of your graph here by going Edit and then selecting your titles, male, female, and you can see it's made the change. OK, and then close the dialog box with OK. So that is just another way to create the graph if it doesn't come out the way you want by highlighting and going into Insert Graph. We still need to make a few changes to this chart. As I said before, we don't keep titles in our charts. So you can click on it and press delete, or you can add and remove elements using the Add Chart Element button over here in the top left under the Design tab, which appears when the graph is selected. So we've removed the title. We do, however, need to label the x-axis and the y-axis. You can see that we have male and female, which may seem self-explanatory, but we have here a list of numbers with no label to tell us what these numbers represent. So if we go Add Axis Titles, Primary Vertical, we can now replace the text with reaction time and include a unit, which would be seconds. And then just click away to set. To go back into the Design tab, we need to make sure the graph is still selected. We can add an x-axis title, primary horizontal, replace the text with gender, and click away to close the dialog. Something else that is often recommended is to check the scale that Excel has set. You can see here that it's automatically set a scale on the side, which begins at 0.395. When a scale is set to start somewhere that isn't 0, it can sometimes exaggerate the difference between your two categories. So it's recommended to change the scale so that it starts at 0 if that isn't the default. To do that, select the numbers in your axis scale, double click, and it opens up a Format Axis dialog box on the right-hand side. You can see here the minimum bound is currently set to 0.395. We can change that to simply 0. And if we press enter, the 0 is now the minimum value on the scale. We can change the maximum value, but that is usually acceptable as it is. You can also change the major and minor units as the graph increases. So at the moment it's going up by 0.05 each time. We could change that if we wished to 0.1, but you can see that that gives us less information. It makes it harder to interpret. You could make smaller increments by changing it to 0.025, and you can see then you get much more information, but if you overdo it, it'll get very crowded and hard to interpret. The important thing is to make sure that the scale starts at 0. We can then close that dialog box when we're happy with our scale. Now, if we wanted to make a different comparison, let's say we wanted to see if age has an effect on reaction time instead of gender, we are now going to want to sort our data from youngest to eldest. So if we click on the top value in the age column, this 13, we can then sort. It says A to Z, but it also means numerically A to Z would be from smallest to largest, whereas Z to A would be largest to smallest. So you can see now it is rearranged, and because I've color-coded the genders, you can see that they have moved around with the other values, which is what we hope to see. The values for the averages have changed because the highlighted sections now no longer show just the male or female groups as they were before. So it would be important to make sure that your data is set the way you want it before you calculate your averages, or we can undo and we can copy, and when we paste the table, instead of making a direct Control V or just paste, we paste the values. That means that it hasn't taken the formula, it's just taken the numbers, which means those numbers now won't change unless we directly edit this box. So I'm going to clear all this data now anyhow, so we can focus on our comparison of age and reaction time. You can see as well the graph will change if you change the values, the averages, the graph automatically changes. Now we're just going to clear that space, sort by age, so under sort, smallest to largest, and we're going to create a scatter plot of age versus reaction time. So we're trying to see whether age affects reaction time. That means that age is our independent variable and reaction time is our dependent. The independent variable should go on the x-axis and the dependent variable should go on the y-axis. If we were to just highlight these columns and ask Excel to do a graph, I suspect it won't come out the way we want it, but let's give it a go. So insert chart, and now we're selecting scatter plot. And the data doesn't really look like what I'm expecting. It might not be too bad. Let's see what happens if we do it manually, see if it comes out the same. So remember, we select an empty space, insert scatter plot to get a blank graph. Now we're going to select our data. We can add a series. It's a little bit different now because it's a different type of graph. We don't need to give it a name again, but we're going to enter the X values and the Y values. So remember I said that the X values, okay, it's going to insist that I do the Y values first. So the Y values should be the dependent variable, which was our reaction time. So I'm highlighting the entire column to enter all the data. We're not using averages anymore. And now I can enter my X values, which is the independent variable of age. and it has plotted a graph which looks similar to the one we had before, but I do recommend that you start with a blank graph and enter your own data manually. Now we're going to remove the title like we did before, and we're going to add axes labels. Horizontal is age, vertical is reaction time. We're going to change the scale. It already starts at 1, but I want it to go up by smaller increments. So instead of going up by 0.1 each time, it's going to go up by 0.05. And we're going to add a trend line to see if there is any correlation between age and reaction time. So add element, trend line, linear. And you can see the new dotted line it is put in shows us that there is a slight negative correlation between age and reaction time. So as you get older, reaction time decreases, which means you're getting faster. It's not a very sharp line, so it's only a slight negative correlation. And you can see that some of the data points are quite far out from this trend line. To find out how closely the data actually fits the trend line, we can get an R-squared value. To display the R-squared value, you can select your trend line, double click, and it brings up a set of options. You can change the shape to a curve rather than a straight line, but usually a straight line trend is what we're looking for. And down near the bottom, you can display the R-squared value on the graph, and you can then always move it somewhere to make it easier to see. If you would like, you can also add the equation. This may be useful because it gives you the slope of the line. So you can see here that the slope of our trend line is negative 0.01. Now that wasn't too short, but I hope it was useful. As I said, I will put a link below in the description so that you can try processing some of your own data.